Programming Throwdown, episode 56, Robotics. Take it away, Jason.
Hey everybody, so I have a new microphone. Super excited about that.
You sound amazing.
Thread. Thank you. There was a Reddit thread. It said, what programming podcasts do you like? On Learn Programming, I think, subreddit. And a bunch of people said Programming Throwdown, which is awesome. Thank you guys so much. And of course, you know, we had to look at all the comments, and like anyone, your brain goes like straight to the negative comments, and you kind of read those. And a bunch of people said, "Oh, Patrick sounds pretty good, but Jason sounds like he got his microphone in a garage sale," which I did. So I actually did literally had my microphone from a thrift shop. So I bought a new microphone. I followed Patrick's advice. And got the same microphone as he did, and I'm really excited, really happy to have some new equipment. I even got a pop filter, so look out.
Oh wait, now you've surpassed me.
Oh, I thought you had a pop filter.
No.
Okay, look out. Now it's like what's that called? Yeah, keep up with the Joneses.
The next thing we need to do is get those anechoic panels that we wrap around when we record, so we don't get echoes and like room noise, and then we'll be professionals.
Yeah, totally. That's the next step. Is that those like corrugated gray foam things?
They have like little pyramids on them.
Yeah, right. Yeah.
I think they're called anechoic.
Hey, sounds good to me.
Sounds awesome.
So on to news. So yeah, this is pretty cool. I would have put it as my tool of the show, but I haven't used it yet. It's still also a bit early, but I think it's a great idea. It's called MARP. Markdown Precision Writer. And the idea is it's this desktop app you download, and then you start writing Markdown, and it converts your Markdown into a PowerPoint presentation. And the reason why that is really cool is the PowerPoint presentation can be packaged as like a website, and in the Markdown you can have HTML. So in other words, like you could have a presentation where in the presentation are some charts that are dynamically generated. Like the presentation could make a web request to, your server and pull back some charts. I mean, in a way that's kind of bad because
yes,
the data could change and not represent what you wanted. That's maybe not the best example, but you could have a link to Google Maps and you actually have the Google Maps, iframe, and it's interactive. And so it's pretty cool. I'm going to try it out. I've always been looking for a better, presentation software. It's kind of more lightweight and things like that. I'm that guy who just has all my presentations are just white background, black text. So yeah, I'm going to try this out, and if it's good, I might double dip and make it my tool of the show in the future.
That's cheating.
Yeah, well, that's what we do. We cheat.
Also, I would hope there's a compiling step or whatever where it generates the PowerPoint and then it kind of freezes your data at that step. No?
Oh, well, you could definitely do that. What you would do in that case is like you would have like you probably just take a screenshot of your data. You know what I mean? Like or something like that. But it can generate this kind of website, or it can export to PDF, which is about as good as you can get. I mean, exporting to like PowerPoint would be really hard. So I don't expect that's going to happen anytime soon. But a PDF is pretty good.
Okay. Well, go try it out and report back.
That's right.
The next story I have was making its rounds. The Apollo guidance computer source code was posted to GitHub. Apparently, this has actually been out in the public several times before. I've never seen it before, but this is some of the code written to control the Apollo mission for the guidance system, and it was written in a custom assembly that they made. But the most interesting things, I guess, are noticed the comments in the code that people wrote and probably assumed would not be written, or at least would not be written, what is that, 50 years later?
Yeah.
51 years later. So things like temporary, I hope that someone deletes this code one day. Yeah, no. And then just, other kind of silly comments and quotes. And I guess things that at the time maybe even weren't that significant, but later reading back, it's kind of interesting to see what people chose. I I guess if you were an author, people would look at this and say, what did they mean here? This is an allegory for what? But it was probably the person just being goofy when they wrote it.
Yeah, totally.
But it's interesting. Sorry, go ahead.
What is the weirdest piece of code you've ever seen, or like funniest? Or, I mean, we've both worked at big companies which have giant code bases, and sometimes you're just diving through the code, you see something completely bizarre.
I mean, I think the only one, and I've probably talked about it before, is the first time I came across it, some bit of code that had a big comment and said, voodoo black magic starts here. Do not alter unless you want everything to crash.
That's awesome.
But other than that, I haven't seen very much funny code.
The only one I saw is, and I might have talked about this too in the past, but there was this comment that said, like, I don't know why, but return 1 here. And the next line was return 0. Like, what?
Yeah. I fussed at someone the other day. I read a comment. No, it was a log statement. And I was like, oh, this is not correct. Your code's not doing the right thing. But in my mind, I had saw the log comment was wrong, and I never bothered to actually read what the code was doing. I just assumed the code was wrong as well. But actually, the code was correct, and they just copy and paste errored the log comment. I was like, oops, should have read the code. But it was fair, I guess, from my standpoint, that if you had why would I keep reading if the comments aren't right?
Yeah, actually, that's something that someone said to me that's really profound is unless you're working on a project by yourself, any code you write will be witnessed by at least twice as many people. In other words, you're going to read it again one day, and someone else was going to read it again one day, at least. And so write code as if you expect it, to be read many times. And I thought that was kind of like a profound statement.
A lot of people still don't follow that, though.
Yeah, no, I mean, we're all guilty of it at different times. So my news article is the Microsoft R client. I haven't tried this. It looks pretty cool. Basically, it's an R front end, and it works with big data. So there's various kind of R operators that you can run on the data to do transformations, do dot product, do things like that. But if you use this R library, let me see if I can find the name of the library. But yeah, if you use this one library, then it'll actually run on the cloud. So you could do a dot product of a billion sized vector with another billion sized vector, and it'll just distribute everything.
Revo Scale R?
That's what it is. Yep. The Scale R technology and proprietary functions. So the deal is the R client is open source. The base, R distribution is obviously open source. But then if you call any of these Scale R functions that are owned by Microsoft, those are closed source. So if there's a bug in one of those, you have to go chase down someone at Microsoft. But yeah, it seems pretty cool. I mean, there's a lot of people who use R, a lot of statisticians, and the idea that they could just kind of take what they've done and move it over to big data is kind of a cool idea. I mean, obviously, you can't do the same things as you can do. You don't have the full power that you do in R because you don't have the same kind of data locality, right? So if you're going to break the data up into chunks, each chunk can only see the data that is assigned to it. So you can't do everything, but you can do a lot of things. And I thought this was pretty cool. I'm definitely going to be checking it out this week.
Pokemon Go.
Oh my gosh.
I'm sorry. I just don't even
So I'll tell you my experience with it. I downloaded it. I fought the test enemy. I think I picked Squirtle, and I fought Squirtle. I defeated him. And so I have, the very first introductory Pokemon. And that's it. So I'm totally lacking. I definitely want to get into it, but I haven't done it yet. But it is insanely popular. So you got a little bit further, right?
No.
Oh, no. Okay.
So I kept telling myself I'm going to download it and try it out because I have fond memories of Pokemon when the original Red and Blue came out. And I was, I guess, I don't remember how old I must have been at the time, but a little on the older side. So as
it's
like
on Game Boy, so you're probably like 9 or something.
But as like a first RPG, it was something that was very good for me, I guess. Japanese RPGs weren't or at least not among people I knew, weren't a big deal at that time. And so I really enjoyed it. But then it wasn't really a cultural thing at that point. It wasn't until later that the cartoon show and stuff started to come out. But by that time, I was a little older, and it was like more something my younger brother and his friends were into. So then I wanted to still play the game, but I couldn't be into it. So now that I'm an adult, right? Like, whatever. But as a kid, I guess I made the decision not to be quote unquote into it. But I still do remember all the Pokemon, and I was always better at the game than my brother because I was older.
Nice.
But no, I keep telling myself I was going to download it, but then I got freaked out because I read some article that was saying that it uses your Google login, and the permissions it grants actually gives it access to like everything in your Google account, not just read email. Or read your email contacts or your email address, but like actually read all of your email. And they're saying it's most likely that they're not using it, but it could be a problem.
They actually just pushed. They posted a news story saying that they fixed that.
Okay, so I will download it.
Yeah, I guess if there's an issue where like once you ask for something, you can't ask for less because that's kind of like giving the illusion that you weren't collecting it when you were. But given that this is already more popular than Twitter, I think like Google made an exception, and like Google engineers like worked something out with them. But yeah, that's so it kind of gets to the article. The article is just, I just cannot believe how popular, and it only came out a week ago, I think.
Yeah,
and it's just insanely popular. Like it's already more popular than Twitter. Nintendo stock went up $7 billion or something. It's just insane. And the article specifically talks about the augmented reality portion of it. So you didn't get to fight the first monster, right?
No.
Okay, so or I guess the first Pokemon. But it does this thing where I don't even know how it works because they don't have 3D vision or anything. It must be based on like passive passive movement. They try to do some kind of stereo vision thing, but
isn't that structure from motion?
Yeah, that's right. So it figures out like, again, in our case, we were at an ice cream shop, and my wife and I were trying it out, and like Squirtle like was just sitting on one of the benches in the ice cream shop, and it actually recognized like in 3D sort of what that represented. And he was just chilling there, and we just flicked a Pokemon ball on him and caught him. And it was just amazing. So yeah, I definitely... So the article talks about how amazing augmented reality is and how it's the future and everything. I believe it. I think it's
interesting that, from what I understand, it's pretty similar technology-wise to Ingress, the Niantic Labs game. But obviously, this has far and away eclipsed anything that Ingress ever was. Yeah, as far as like the amount of people, the cultural awareness of it.
Yeah, it started as an April Fool's joke in Google Maps. This is the article talks about this. And I don't even remember exactly what the April Fool's... I mean, I remember seeing it at the time. There's some April Fool's joke that like juxtaposed maps with Pokemon. I don't know if it replaced all the buildings with gyms. I don't know. But it was insanely popular. And then they realized that there's this huge, a Pokemon fan base that they could tap into.
I will be downloading it. I will be playing it. I will probably show my kids how awesome it is. And they will think I'm an amazing person for being able to capture Pokemon.
If you don't see us, if we don't have an episode next month, you'll know why. We're running around trying to catch Pokemon.
I saw articles devoted to selecting an external battery for your iPhone because it drains so much battery.
Oh no! I guess a GPS.
I have no idea, but it was just funny that everyone's trying to cash in on the clickbaiting by putting Pokemon Go in your headline.
That's awesome. Next episode we'll definitely talk about it more, as we would have hopefully played it by then.
Book of the show.
Book of the show. My book of the show is the U.S. Puzzle Championship 2016, which just happened. You can go to this URL if you click on the show notes, and you can download the puzzles for free. The contest is over, so you can't compete this year. But I did compete 2006 through 2010, and I wasn't like particularly that good. I think it was in like top 100 one year, but like I didn't get to go to the World Championship or anything crazy like that. But it's super fun. You don't have to be a programmer, although you can actually use the computer to kind of cheat. In the actual contest, they give you 2.5 hours, and so you kind of have to sort of solve these logic puzzles by hand. Because I guess you could cheat. You could write a bunch of scaffolding code, and in such a way where you could quickly churn out a program. But as far as I know, nobody actually does that. And if you did that and went to the World Championship, they don't let you use a computer, so that would be kind of weird. But you can actually use a computer to solve the puzzles, like brute force it or whatever. It's kind of a fun exercise. You can also solve it yourself by using various kinds of like reductionist methods and things like that, and logic.
So what is an example question? Or what are the kinds of questions that they ask? It's like Sudoku puzzles? Like
no, it's kind of. So you could think of Sudoku as like a logic puzzle. And so this is just sort of like an umbrella of which Sudoku, could be one of the questions, right?
Sure.
So they're basically variants on that theme. So there's some where you have a bunch of different weights and you have a bunch of different scales, and you have to make all the scales balance, but use all the weights, for example, right?
Mm-hmm.
They're all variations of MP hard problems, but
they're not like find an algorithm and then run it. It's just like solve an instance of the puzzle.
Exactly. Right.
Okay, so they give you some rule set and an instance of a puzzle, and then you're supposed to solve that instance of the puzzle.
Yeah, exactly. That's
okay,
right.
But they're not puzzles you would have seen before.
Right. That's right. But yeah, it's the thing about it is like you can't brute force it, so you often have to find like some tricks to like radically reduce the search space. And so if you have those tricks, then you could write the program pretty quickly. But if you have the trick, you don't need the program, unless you have to solve like 1,000 of these, right? So that's really what it's all about, is like trying to understand the patterns and trying to understand like specifically like what things cannot happen so that you don't have to think about those things. Okay. And then once you've got it narrowed down, then you just try all the possibilities. It's a lot of fun. I mean, I did it for a long time. I wish I could say I was good at it. I'm definitely better than like an average person, but I'm not anywhere near as good as like these like world champions who are just crazy.
That was a humble
crazy
brag.
In a good way, but yes, yeah, but yeah, it's true. But anyway, so this is really fun. You guys should definitely try it out. They also have solutions, so you can make sure you're on the right track and things like that. So definitely check it out.
Sounds like homework.
Yeah, that's I'm trying to figure out like I think the reason why it's fun is it's like Sudoku. If you like Sudoku and you're tired of doing kind of the same puzzle just with different numbers, then this will blow your mind.
But I feel like a lot of the appeal of Sudoku, I don't know how to say it, is figuring out those tricks and then getting to apply them over and over. And for me, it eventually becomes boring. But you can kind of have your personal pattern or tricks, or you may even know tricks but choose not to use them just because you like doing it more casually. I feel like it would be difficult. I'll try it out and see. I feel like learning a rule set for a single question and answer is less interesting to me.
Yeah, I think it's I feel like there's two types of kind of satisfaction, and this is getting to like psychology or whatever, but there's people who like get satisfaction from novelty. It's like, oh, I saw this thing I didn't see before. Like, oh, I went to Machu Picchu and I'm just happy because I did it. And then there's people who are like, I played this guitar song like more accurately than I did last time, and that makes me happy, right? And so the people who do Sudoku every week are in category 2, and this is like category 1. So it's like a different kind of satisfaction.
Yeah, I think I'm more in. Well, I just said category 2, but I think I'm more category 1. I typically do like find enjoyment for the first little bit of something. So I guess that contradicts my statement. Yeah.
Well,
I should try this. I will report back.
All right, sounds good.
So you're going to tell us about MARP, and I'm going to tell us about this.
That's right. We have homework.
Someone will remind us. My book of the show is Son of the Black Sword, which is a fantasy book by Larry Correia. And I've had him as an author for books I've picked before. Oh, actually, I think I accidentally picked the same author 2 shows in a row. Because I believe
that's fine, as long as it's 2 different books.
believe I had Hard Magic, which is a different series that he writes that last time. So anyways, I'm obviously having some sort of thing with this author. And I listened to this book.
He's not sponsoring the podcast at all. No, I'm just kidding.
Yes, if you would like to contact us
yeah, right.
and send us money. But I listened to Son of the Black Sword on my commute. I really enjoyed it. It's a fantasy book. And sometimes traditional fantasy books get a little bit weird. The first one, because they're kind of doing a lot of world building. But I felt this book struck a really good balance of world building and also having an interesting story that had some progression from start to end. Obviously, it didn't like tie everything up because it's a series. And it actually didn't have as much of an end as many books do. But it did have a clear trajectory, and I felt like there was, on its own, you could just read this story. Oh, no. I'm trying to say you could read the story and be happy with where it is and not have to read the next one. But it kind of, I don't want to spoil anything, but that's not completely true. So anyways, check it out if you're interested in fantasy. The concepts I felt in it were pretty original to me. Sometimes I say that, like, oh, this fantasy book had this idea that I thought was really cool. I'd never thought about it that way before. And someone tells me, oh, no, that's actually from some older book. And this author just kind of was rehashing it. So I won't say that this is original, but to me, some of the ideas that were in this book were kind of novel, and I found them interesting. So that's Son of the Black Sword by Larry Correia, and we'll have the link in the show notes. Or, we are sponsored by Audible, and if you go to audibletrial.com/programming throwdown, you can get a free 1-month subscription to Audible, which means you can download any books. You could download Son of the Black Sword, or there's many, many books on there. We've a whole host of books that we've recommended, or I guess mostly I've recommended. Jason's book isn't on Audible. U.S. Puzzle Championship 2016.
Although I did, I am halfway through Red Shirt.
Oh, yes.
One about the
Star Trek.
The Star Trek thing. Yeah, that is an awesome book.
Oh, you're enjoying it. Good.
Yeah, it's very fun.
Good. Yep.
Yeah, it's actually I'm glad you didn't spoil it when you gave your review because.
Well, don't spoil it now.
Yeah, I know, but I was totally not expecting, what happened, and it was really really awesome. I mean, it's like I'm really into it now.
Okay. Yeah, it's really hard to do these because I feel a lot of a book should be a surprise, and I actually tried to read as little as possible about the books, just enough to kind of know I'd be interested in before listening or reading them. And so so I always feel awkward giving the review because I don't want to say too much. Like I didn't say anything specific about Son of the Black Sword. You have no idea what it's about other than there's probably a black sword and somebody who's a son. But yeah, I just don't want to give any of the surprise away because that's like a lot of the awesomeness of reading a book.
Yeah, totally. So we're also on Patreon. So you can go to patreon.com/programming throwdown, and we'll have a link to that in the show notes as well. And that's where, if you feel inclined to like give a donation each episode, we also post, MP3s on Patreon. They have a pretty high bandwidth connection and all of that. So yeah, Patreon and Audible, check it out.
Yeah, and thank you to all of you who have been doing both of those things. We really appreciate it.
Yeah, absolutely. Time for tool of the show. My tool of the show, given the whole theme of sort of robotics and kind of more hardware.
This is a little bit of a stretch, but it was a good idea.
Yeah. My tool of the show is I'm not going to say this right, Evoluent vertical mouse. And so I've had actually this Since you and I met, I've had one of these mice for work. I don't have one at home because this would be useless for gaming. But if you sit at a computer doing programming for for a living, or just for a lot of hours, this mouse is awesome. It's a vertical mouse, and so it's very hard to describe. Maybe the
No, I don't think it is. It's if you
is,
put your hand straight out. Normally, you hold the mouse with your palm towards the desk. Instead,
Right.
you hold it with your palm facing your keyboard. If you're right-handed or left-handed, with your palm facing your keyboard, and then you make like a pincher motion with your thumb.
Yeah, like imagine if you're gonna shake someone's hand.
Oh, there you go.
That's kind of like what your hand is going to look like or feel like all day. And it's really, it's one of these things like you might say, well, who cares, right? But I actually noticed when I when I switched to a regular mouse, after about a month, I could kind of feel like the tension in the shoulder and things like that. And so this is, I think and I'm not like a
Ergonomics.
ergonomics, expert or anything, but what they say is, I guess when you tilt your hand, palm down, you cross the two bones in your forearm, and that causes stress, especially if you do it for many hours. So yeah, the Evoluent vertical mouse, it doesn't have to be that one. That just happens to be the one I've always used. I'm sure any vertical mouse would be great, but yeah, check it out.
There's a whole host of ergonomic solutions. Weirdly, I did have one of these mice, and it was still bothering me a little. And so the thing that worked for me was even just using a normal mouse, but using it with my left hand, even though I'm right-handed.
Oh, I have a friend a coworker who sits next to me who does that. He actually alternates. So
I do somewhat as well.
Right-handed.
Yeah. I do have two mice plugged into my computer, actually. But I find for some weird reason, I guess because I do a lot of other tasks with my right arm, that using my left arm for my mouse works really well for me. But then people fuss at me because most people who use their mice with their left hand swap the buttons. So I'm going to get this wrong. Normally to right click, it's the right button, but you make it the outside.
Your index finger should be the main click, right?
But I don't. I leave it. That is too confusing to me.
Oh,
so
I
leave it in the normal orientation. So I use my middle finger to do the main clicking.
Oh wow!
I'm weird.
You must be really adept at navigating traffic. Like your middle finger is just ready to go.
I didn't even know what you were saying.
I was trying to figure out the right way to say that.
All right, moving on.
That was not the right way to say that.
Moving on. Awkward joke. My tool of the show is a 3D printer, trying to be in theme as well. If you get into hobby robotics, you'll definitely want to have a 3D printer, or it won't hurt to have one. And I got one. We talked about 3D printers a couple times on the show.
Yep.
And I don't know if I've talked about mine, but I did end up building one from a kit. It's kind of a low-cost one, a version of one of the RepRap Prusa i3, or Prusa i3. I don't actually know how you say that. And it's a variant of that. I'm enjoying it. It showed me a lot about that kind of stuff. I've had a good time. I printed a lot of things, some functional, some playful, and then kind of painted them. If you have little kids, it's kind of cool because they think anything you print, they call it the robot. So like, Daddy, I want to go downstairs and watch the robot. And they just watch it kind of like zig and zag around. But then you do kind of get into these stages, or I have a couple times where it requires a lot of, or because mine's a low end one, I guess, or budget one. But I think the high end ones do need this occasionally too. It needs like a lot of tuning to keep it in a good state. And so sometimes it gets like out of calibration or whatever. And you spend several like sessions where you kind of just want to go down and print something, but it's not working and you're trying to like fix it. So you spend a fair amount of time doing that.
Gotcha. Do you have one that you recommend? Because I've always wanted one.
So the one I have has a specific set of problems that I felt were okay within my wheelhouse for me to save some money. So mine is the Folger Tech 2020 i3, which means that it uses aluminum extrusion 20 millimeters by 20 millimeters. And it's the Prusa i3 variant. So it's relatively cheap. But the quality control isn't great. And the instructions, although adequate, you need to be used to building kits of things, specifically hardware things, before, or you'll probably be very confused. So like how to get it into kind of orthogonal conditions where all of the various pieces are aligned properly takes a fair bit of kind of knowing how that should work to know what to loosen and what to tighten and adjust. And, and have it help you.
I can't even build IKEA furniture.
Oh, so. Yeah, then you do not want this one. Okay. So then there are ones that are, moving up the price scale, but like a lot of people recommend the Lulzbot Taz. I've not used, I think they're at Taz 6 now. But that one seems pretty good. You can look, there's a lot of communities on Reddit. The RepRap community is pretty big. And there's a lot of clones from China and elsewhere that are varying levels of sophistication and goodness or badness. And it all depends on what you want to do with it and how hands-off or tinkering you want to be with it.
Gotcha.
But in my mind, half the fun is printing the upgrades for the machine. Like I've upgraded a lot of things on my machine, and I derive enjoyment from that.
Oh, I see. Like what's an example of an upgrade you would print?
Sure. So, this is going to get really detailed and hard to explain in words, but in this style, the bed moves forward and backwards, but not left or right or up and down. So the piece of glass or PCB that you're printing on moves only forward and backwards. Then there's a set of screws that hang down from the top of the machine that the actual print head rides on and moves up and down, and then another motor to move it left and right. So that assembly can slide up and down on these screws. But the screws they ship with it are this like cheap, same thing you would use for like low-end bolts. They're not actually what you would typically use for a control system like that, a high quality screw. And so I switched out those screws to the more high quality screws. They're called lead screws. So that as it moves up, it does it more precisely, which means the prints are more even in each layer. And so you get a little less noise.
You didn't 3D print the screw, right?
So you buy the screw, but then how the screw connects to the side holder parts. I don't have the technical description, but like that needs to be 3D printed because it uses a different nut than the original one. And so you 3D print that. I 3D printed like little feet that go under the bottom so that when it vibrates, it doesn't vibrate the table. So it's quieter.
This sounds so fun.
3D printed like little holders to like, route the cables. Just like all sorts of little things.
Yeah, I mean, I've had so many like things I've wanted to 3D print, but I don't have. I have access to a 3D printer now, but for a while I didn't have access to a 3D printer, and even like the Thomas the Train like wooden train tracks. Yeah, like if I had a 3D printer, I mean, oh my gosh, like it would be so epic.
Yeah, so I did print like there's a set of low polygon count Pokemon models that my kids love. So I've printed them. I don't even know how many now. Like little Bulbasaurs and Squirtles and Charmanders. So they love those in theme with the Pokemon Go. And like I printed a lightsaber. So like the lightsaber hilt or whatever and a bunch of pieces. That was pretty cool. So I've printed a lot of things that kind of just work pretty seamlessly. And then now I'm trying to get into kind of designing my own parts for various ideas that I have. So that goes a little slower though.
Very cool. All right, talking about robotics.
So this will be a little different in the structure of how we talk about it because we could talk about the history of robotics, but I don't know.
I mean, it's probably enormous and not that relevant.
So the reason why I find robotics interesting and the little bit of work I've done with it from the hobbyist and not is that it's a lot of systems that need to work together to kind of have a robot. And so we're going to kind of go through each of some of the various subsystems that make up a robot, because a robot is different than just an application where it's a binary running on a computer. It is often many different applications. They need to do a variety of different things. And to be a roboticist, I guess, you often have to know a huge spectrum of different areas of expertise because they all are needed for having a successful robot. So the first one that I guess everyone kind of thinks about, and I'm not going to talk about, since this is programming throwdown, we're going to talk about this as it applies to software. So we're not going to talk about things like mechanical design of the robot, but that is also a very interesting topic. So the first one is the things that move or control or interact with the world and the controls for them. So these are, you could think of what moves the robot. So most robots we think of move around the world in some way. So maybe it's wheels that are attached to motors, and those motors spin the wheels and move the robot forward. Or you have, a robot arm, and it has actuators, little motors at each joint. It could be, I'm trying to think of other things, treads for a tank style robot. There's all sorts of different things about how do you move a robot. And then there's things about manipulating the world. Like I have a little claw and I want to grasp the world, or I want to, I'm trying to think like things where you want to interact with something physically in your world versus just moving through it. A lot of these have that in common. They're combined with what we're going to talk about next, sensors, but you have some sort of motor or a electromechanical muscle of some sort that's moving, and you need to control that. And so there's software that needs to be written to say, if I want to move precisely from 1 millimeter forward, how do we do that? And there's kind of two approaches there, and there's a lot of software around this, but one is open loop. That's the easiest. So that is, I know that if I have a stepper motor, which each time I kind of move the stepper motor forward, it moves a set number of degrees. So like 1.7 degrees forward. This is
like, I guess if you had a tire.
Yeah.
And you know that if you rotate the tire 360 degrees, the radius of the tire, you can kind of guess pretty accurately how far you're going to go.
So that's a great example. So if you're kind of like roll forward on a tire, you wouldn't necessarily do that closed loop because there's a big problem, which is as you roll forward, the tire probably slips a little. And so at the end, you don't exactly know how far forward you went. So even if you have an encoder on the wheel to see physically how much did the wheel move, you aren't able to measure like via the wheel itself. You aren't able to measure if it slipped at all.
Okay.
And so that would be kind of something you would do open loop most often. You would just kind of drive it, and you would rely on some other sensor to tell you how far you went. But then you have closed loop. So closed loop is like a servo. So if you've ever used a servo of any sort before, you kind of tell it to go to a specific angle. So like I want to go to angle 90, and I want to go to angle 95. And it has circuitry inside of it that tries to keep it at that angle. So even if you go push on it, it'll try to go back to the set position. But there's software in a lot of these systems that does that. It's called closed loop. And this is where you get into stuff, if you've ever heard PID, which is like proportional integral differential or derivative control. So this is a way of keeping something at a set level. And this gets into control theory. And in closed loop, you're sending out a control signal for something to happen, and then you're measuring what happens back. And you could have all sorts of problems where you don't want to, but you're trying to go for a certain position and you overshoot it, and then you need to move back. And there's all sorts of math around how do you try to prevent overshoot? How do you try to prevent that, like over time it stays very close to it? And so
does this involve like calculating the gradient or something, and like moving like step, like adaptive gradient or something?
Yeah, so this is like, so there's different ways. So there's like like I said, the PID loop. Other things you'll hear about sort of in this arena are like Kalman filters start to come in, come into this. This isn't meant, we'll probably later go into more topics. This is kind of giving you Google words that you can go search, or maybe context if you've heard some of these words before. But this would be, closed loop is trying to say, how do I have a desired outcome, and then how do I make sure I achieve that outcome in a good manner?
Gotcha. That makes sense. So closed loop has to be something kind of simple, like turning a rudder on a boat or something.
Yeah, holding
like
a rudder at a specific position on the boat. Yeah, or holding a robot arm at a specific level, or even things like, we were talking about before, like a 3D printer. So my 3D printer has like the nozzle that heats up the plastic. You want to hold it at a very specific temperature. But that's not as simple as just setting an amount of current to flow through, because as the room temperature changes, as plastic flows out, like cold plastic comes in and then hot plastic goes out, the temperature moves around a lot. And ideally, you would like it to be very stable at a very specific temperature. And so there's a control loop where somebody in software is measuring from a thermometer the temperature of the piece of metal that is the nozzle, and controlling the heater that heats up that piece of metal. And so there's actually a control loop running there to try to keep at a very stable temperature.
Okay, that makes sense. So do you have it sounds like with closed loop, you just like someone else has kind of done it for you. But with open loop, the kind of onus is on you. Like maybe you have a camera or something and you're the one who has to say, I'm really close to the wall right now or something like that.
Yeah, so I mean, open loop, so these are just, it's kind of separate from actuators. How do you control something? How do you move? And then these are various ways when you move things, kind of how are they moved, whether you do them in open loop or in a closed loop. So for things like sensors, there's a whole bunch of questions. So you could use a sensor to try to, you'll hear people say, close the loop. So I moved, I told my robot wheels to move forward. And we talked before about structure from motion. Like I look at the camera and tried to guess how far forward did I move to quote unquote close the loop. So that even though I didn't measure anything about the motor, I looked at the world around me and say the world shifted forward a foot. Therefore, like I know what I just did to the motor. If I do that again, I will most likely move forward 1 foot again.
Oh, is that where the phrase close the loop came from?
They're related. They're related. I don't know which one came first.
That's interesting. Well, it's interesting. I never thought about, every time I've said close the loop, it's like, talking to somebody or something.
Yeah. So when you close the loop with a human, you did something and then something happened, and closing the loop means like getting feedback back so you know what to change next time.
Yeah, that makes sense.
Yeah,
that makes sense.
So
the camera gives you the feedback.
Yep.
That potentially could give you the feedback that then turns into more actions for the wheels. That then changes the camera, and so now you have a closed loop.
Yep. And so there's things like for sensors themselves, we'll talk about in a second. But like you have often you'll have a camera and you want to point the camera at a specific direction, but if you think about quadcopters are really popular now, these helicopters with 4 blades, but they kind of move and bounce around in the air. It would be ideal for some of them if you held the camera pointing at a very specific thing. And so how do you do that? You have a set of motors that are able to move the camera, but they need to monitor what the quadcopter is doing and kind of cancel that motion out. And so that's a closed loop system, that gimbal system for trying to control that camera. And that is so that the sensor, the camera itself, gets a good image. And so then there's a lot of work associated with sensors themselves. So we talked about a lot of things there for sensors, but someone still has to write the code to talk to these pieces of hardware and like read. Ultimately, they're probably producing some electrical signal, or the hardware itself is producing bytes that need to be read. But you need to interact with those pieces of hardware and make it into something that the rest of the system understands. So for a camera, that would be reading out a single frame off the camera. For an accelerometer, it would be, configuring the range of sensitivity for the accelerometer and then reading out the current acceleration that you're experiencing. So there's a lot of work around how do you do that for the sensors? How do you read it in? How do you put it in a format that makes sense for the rest of your system? And then how do you do it at like a set interval quickly enough so that you're not, sometimes I read it a little early and sometimes I read it a little late, because that can cause problems with some of the stuff we'll talk later. But a lot of things in a robotic system are assumed to be running at a very specific rate. So this is similar to like in a video game, you want it to run at 60 frames per second. And so you want everything to kind of always be at that. And if you had 60 frames in a second, but you had all 60 right at the beginning of the second, it would look very weird. So you actually want 60 evenly spaced frames. And so that's called the jitter, how much time, the time between frames, how often it does. And so when you're reading sensors, you're trying to kind of reduce jitter, make sure that you're reading it at the set rate. And there's a lot of work about that as well.
Gotcha. That makes sense. A big part of robotics too is planning and autonomy. So one is autonomy. So one is like teleoperates. This would be like, I guess, using a joystick, and just when you press a trigger down, the helicopter blades turn faster or something like that. There's also just purely autonomous, where you give it kind of very high level instructions, and someone's built all sorts of layers of I guess, machine learning and different kind of planning systems. So in other words, like the very top layer could say, fly to this spot on a map and then fly back and land. And so at that level, if you're doing any sort of machine learning there, you're probably not doing any machine learning there. It's probably a human putting in certain commands based on sort of changes that they want to make in the world or things that they want to see in the world. So that's sort of like human level decision making. Then when you kind of go down in the stack, it would be things like there's usually some kind of state machine where it says, okay, am I landing? Am I taking off? Am I flying to a destination? Am I, trying to take a picture or something? I'm thinking of drones here, right? And at the bottom level are things like are kind of like a system for each of those states. Like, the drone is taking off. Here's sort of a bunch of logic to kind of handle the takeoff scenario, and ditto for all the other kind of scenarios.
Yeah, I think each of the different, if you think about subsystems in, for instance, like a quadcopter, you have something that's trying to keep the helicopter afloat, like don't crash. But then you have something else trying to say, move forward. So there's an interaction between like go forward and do it stably. Like you don't want it, kind of going crazy. You want it to go forward smoothly and deal with any kind of disturbances along that. And then, as you said, there's something more, which is like, I'm trying to get from point A to point B. And so like, what's the best path to get there?
Right. And another part of it is like supervised learning. And so what this is like, what's a good example?
I should have done this as a tool of the show. I've been doing the Udacity machine learning class with Sebastian Thrun.
The self-driving car one?
Yeah. Yes. And he talks in there. So this is actually, I definitely recommend that. I've never really sat down and did a massively online class, but I finally did, and I did it with this one. And I cheated. I didn't really do the homework. I just been watching all the videos.
How are you going to do the puzzle contest if you can't even do the Udacity homework?
But I've been watching, and I found it, really a good, well put together series. And so if you're interested in robotics, I would definitely recommend it. And so the example they use there in supervised learning is that when you're driving an autonomous car, you want, for instance, to decide if the terrain you're currently driving on necessitates that you drive fast or slow. And so over time, they collected a bunch of data when they were driving a car and looked at things like the accelerometer for how bumpy the road was. And I forget, they used something else as an example. The current gradient, like whether it was flat or steep or very steep. And so they recorded these various things while they were driving and produced a data set where the label was either they were driving fast or driving slow. And so supervised learning would be giving that to a computer and then saying, hey, next time I give you a current bumpiness and gradient, I want you to tell me if I should drive fast or slow. But I give it a bunch of examples of what I did to supervise it and how to make that prediction.
Right. And actually, they did the same thing for AlphaGo, the world champion Go player. They actually, because if you imagine, like in Go, there could be actually many different ways to play really good Go. And trying to find all of them or trying to find one of them could be really, really hard. So what they did is they said, let's take all of the games played by all of the world champions. And in the beginning, when they just start learning, instead of trying to have the computer play Go against itself and get better that way, which is what they do later. But in the beginning, they just say, look, computer, this was a game played by two experts. The next time you see games like this, I want you to play as good as these experts do. So like, in other words, take this bank of games played by these experts and try to generalize it. And so this changes the objective function from, play the best possible game of Go to just do what these experts do, which is much, much easier. And then that was sort of a scaffold. Once they have that, then the system is kind of already tuned to a certain spot of the search space. So in other words, like to illustrate, like if all the experts in Go for some reason always place the first stone on the bottom left for some reason, like it's just a thing, then you could learn all sorts of cool strategies where you don't do that, but it's not going to help, especially if you're going second. So you might as well learn what the experts do and then optimize after that. And so the self-driving car is the same way. You can't just, train a model and then have a self-driving car like go on version 0 of the model. It'll just drive off a cliff, like, it'd be a disaster. So instead, you build this supervised model, and then you can even, while you're driving, see, what would the model do? If you're going 45 and the model says I would go 130 miles an hour, then something's like really busted.
Yeah. And I think interesting you talked about like levels. First it's kind of remote control, then you kind of move up. And if you think about like autonomous cars as an example, even though the end result, you want a fully autonomous car where you just say, I want to go to the grocery store and it just takes you there. You kind of, as you're building up that system, you take it through various levels where initially you just want to test that you can kind of tell the car what to do and it does it. Then eventually you're kind of monitoring what it does, like allow it to do some stuff. So that would be like cruise control, like set the car on cruise control and it knows to just try to keep that speed. Then, you're giving it a task, go the speed and stay in a lane. Then you're going like, okay, now I want you to figure out how to change lanes on your own. And then a step past that, it's like, I don't care how you do it. You pick the roads, you pick the lanes, you pick the speed. I just want to go from here to here. And you kind of take it up through that level of sophistication.
Right. Yep.
And that's something that we still haven't done with a lot of systems. Like we don't have a lot of fully autonomous systems. Even things like the drones you hear about being used for war aren't autonomous. And it's scary what will happen when they finally do go fully autonomous. But you don't tell them, protect this area or, go take this action. They have some combination of humans telling them, fly this way and get home, right? But like they aren't sitting in an area looking for something to do. We don't have robots that yet, or at least not commonplace, where a robot kind of replaces a mall cop and there's just a robot, sitting in the mall watching for bad behavior and then like setting off a siren if it sees someone doing something bad.
Yeah, exactly. I mean, there's this saying, there's this sort of like thought experiment, if you have a robot made and the kids are like really hungry, what's to stop the robot made from like microwaving the cat? It's like you need like all of those kind of really higher level things that involve sort of the fact that like, different, like the fact that like, ants like have a different like level of feelings as a cat, and so you could step on an ant, you can't step on a cat. Like these things, or you can't kill a cat, I guess. These things are like incredibly entrenched in like our psychology and like very difficult, and we haven't even like begun to sort of like crack these problems. So yeah, as Patrick said, I mean, because you hear so much about Skynet is coming, things like that, and it's not. Like we're so far away from that.
Yeah. And so that's where the machine learning, I think, comes in. Is we talked first about controls and motors, and then we talked about sensors. I mean, these things are highly deterministic and highly straightforward, part of robotics. And once you have them working, you can kind of have a remote controlled robot, I guess. But the machine learning comes in when you start trying to say things which are a little more non-deterministic. There are many ways to accomplish it. And what Jason is indicating is exactly right. Just because we have something which can do a relatively mundane task doesn't mean we're suddenly close to something that knows how to do all tasks.
Yeah, exactly. Or even something that is self-aware, like that knows that it's doing a task and sort of what that means, right?
So then another something to consider with robotics is often you may have many processors for a large robot in the system, all responsible for doing different things. Like one's responsible for collecting all the camera data. One's responsible for collecting the sensor data. Another is responsible for route planning. And so all of these systems have to communicate with each other, and there needs to be, often they may not even be the same kinds of processors. Like some may be very small, low-cost processors. Some may be high-end, fancy, very good processors, and you need a common way for them to interact and communicate with each other. So that's something that as a roboticist you have to work on and debug. And then also sometimes you need a communication off of the robot. So how do you keep a log of what's happening? You call that telemetry. What if you want to talk to another robot and the two robots should coordinate to do a task? Now you need a distributed algorithm for deciding like what to do with multiple robots. And this is where you get things like swarm robots and swarm intelligence. And that's another interesting exploration area of robotics.
Yeah, I've seen a lot of there was this paper that came out a long time ago. It was called Boyd's, and the whole idea was they studied a bunch of different bird. This person was fascinated with how birds fly in like a V or different shapes that are very geometric, and how difficult that must be from within the frame of reference of one of the birds to sort of understand how to orient itself. And what it found is if you have a few simple rules, you can actually get that flocking kind of effect. I mean, the rules are very simple, like, get a little bit away from the birds next to me, but not too much away. It was kind of like a force-based, like a graph force-based system. And so I think that that's a big part of it, is understanding like when you have many different robots, sort of how does that complex adaptive system work? And there's a lot of really interesting research there.
Yeah, so like emergent behavior and...
Yeah, right.
Yeah. That's a huge area of research and, a very interesting thing to look at and understand.
Yep. Another part of this is HCI, human-computer interaction. And I think it's also called human-machine interaction. And this is just about sort of how you interact with the machines around you. The name is very straightforward. But, for example, the touchscreen is kind of one of these things that's gone in and out of vogue. I mean, I remember when there were touchscreen laptops, and then people realized, a lot of people realized that doesn't really make sense. And then there was the Newton, where it was a phone like, form factor, but it had a stylus. And now we have the iPhone, style, right? And so these are all just advances in HCI. And they can cause like radically different user behavior. Like if I have to pull out a stylus, then that adds friction to the experience. I might not do something quick like send a text message or check my email or something. And so it's just hugely important, and it's kind of like that kind of gets right on the border of robotics, because it involves a sensor and it involves kind of the outside world.
Yeah, and I think the difference with robots than just like how do humans interact with machines is also robots move about in our world. It sounds a little weird, I guess, and humans perceive them out in the environment. And so you need to understand, how do you want people to behave around the robot? Do you want them to ignore it? Do you want them to, be friends with it? Right? These are questions that are still like very large open research projects. But things like the self-driving car, like what happens when you get into it, and when you're sitting in it, like how does it make you feel? That sounds really weird, but ultimately, if you don't feel safe because of the way it's driving, even if the way it's driving is better than the way humans drive, you're probably going to be really freaked out. So
yeah, even if Elon Musk tells you everything's going to be okay.
Yeah, so maybe they need like a little Elon Musk head to come up and say, welcome to our car. Right, but these are all things you have to think through if you have a machine out in the world. And then there was that movie about it, but I don't remember, where the assistant on your phone, and people kind of develop a bond with it and call it by name. And instead of saying it, they say he or she.
Is it iRobot? Is that right?
No, iRobot is a different one.
Oh, okay. I know what movie you're talking about, but I also forgot.
I didn't watch it, but yeah, basically this is a real thing, that if people project emotions onto these, or what are you wanting to evoke? And so this is things like when you call into a phone line for customer service, right? That they call that a robot. I didn't actually think about that until just now, but like I guess a phone answering robot. But they want you to efficiently get to where you are. But they need you to behave in a certain way to kind of get that. So they have to interact with you very specifically. It's the same thing goes for robots, that how should you put little eyes on the robot or not? what like people will react differently depending on what you do. So
yeah, actually, I saw something pretty awesome in the city, in San Francisco, downtown San Francisco. I saw on a light pole this poster that said, gone missing. And it was like they had taken the template of, I guess if you lose your dog, most people just go into Google and type like, I lost my dog. And there's some Google Doc template because they all seem to look the same. And, it has little things where you could tear off the bottom and call the number. But it was a person's Roomba. Like, I guess the battery ran out in their fence and the Roomba just went out of their backyard and went down the street or something. And it was like, lost Roomba. Like, if you find him, please cuddle him. It's just
wait, that sounds like it was just a joke.
I don't know. There was some. Well, we'll see. I think it was written in a funny way, but I think the person legit lost the Roomba.
Okay. Yeah.
I do know a lot of people call the Roomba like him or her, like or at least they have a name for the Roomba. So
interesting. So then I was just to close out going to talk about various things where people hear about robotics. We already talked about self-driving cars, drones. These are things, but also there's FIRST Robotics. So I think they have various degrees for middle school and high school students, and these are remote controlled robots. Because at that level, I think there's some opportunity for them to perform some autonomous tasks, but they're also remote controlled because autonomy is very hard. Then Robot Wars, which I've been watching, which is like, I guess, entertainment TV. And there are some of the systems we talk about, like control systems and stuff, but there isn't much sophistication in the terms of autonomy. Although a couple of the teams do talk about things that they've tried to make automatic. But there are also, what is the name? The Robot Cup, is it?
RoboCup.
Yeah, where robots play like a version of soccer, right? And they try to do it autonomously.
For people who don't know, the goal of the RoboCup is to have a fully autonomous robot team that can play the World Cup winners in 2050. And it's a pretty audacious goal. But yeah, I mean, they tackle like every level of the problem has a competition. Like there's a competition for who can build the best like humanoid player, who can build the best like 1 foot tall player, so on and so forth. Like there's a whole competition for who can build the best AI in like a pure virtual sandbox. RoboCup is amazing.
And it's an interesting problem, which is if the goal is simply to beat the World Cup team, do you have you still obviously probably have to obey the World Cup rules, so you can only have like 11 players. But do they have to be shaped like humans? I don't know. Like some of the rules in soccer probably only make sense for humans.
Yeah, they're shaped like ankle-destroying tiny robots.
But even if you don't something ridiculous like that, like it just might be like very short, stout barrels, right? Like maybe that turns out to be particularly optimal. But then now like the rules about using your hands or not like don't make a lot of sense. So I think the implication is to do it with humanoids. But it's actually a broader problem for just all of robotics. If you're designing a car assembling robot, it's all about function and very little about form. But if you're building something that's out there with people, form starts to matter a lot more.
Yeah, right. It's actually like super interesting to read articles and other sources on sort of things which have taken like inspiration from the human form for no reason. Like the example they gave, which I don't know if I really agree with, they said like the driver in a car sits on one side of the car, and I guess they were arguing it would be better to have the driver sit in the middle and have two people on either side, like have the car be a little bit wider. Like I don't know, I thought this kind of weird, but their whole thing was like, a human being is asymmetric on the inside because of your heart and other things, right? And symmetric on the outside.
What?
Yeah, they were trying to draw an analogy between the asymmetry of the inside of a human and the first designs of the car. And I don't know if... Yeah, that seemed pretty out there. But they had a number of other examples too. But I think it's kind of interesting. And I think over time people learn, in the case of something that's purely functional, like a robot, a car building robot or something, people eventually get over sort of their own human bias and learn like, you actually don't need something that has an arm, like a human looking hand or claw.
But if you're going to have a robot made in your house, it needs to open doors and cabinets. And obviously those things are meant for human hands to grasp.
That's true.
And so then you're kind of forcing the robot to have certain features, which even if you don't otherwise intend, it needs to be sort of human-like height to be able to reach, for instance, tall cabinets, have sort of human-like grippers so that it can manipulate things designed for humans to open. Or you're forced to like retrofit everything in your house for, like, it wouldn't be good for both humans and robots. It would be good for either humans or robots, unless the robots also look like humans or the humans look like the robots.
Yeah, or maybe like the drawer is like a hybrid where it has a little hole that the robot can, like stick something in the hole so that they have leverage. I don't know.
But then the adoption problem is hard.
Yeah, right. I do think I'm surprised that by now there aren't self-cleaning toilets where like the toilet has just something in it that just, like goes around the bowl and like cleans it.
Just seems like it would be something that would break a lot though. And
really?
Like a toilet is a very simple piece of equipment. Like if you complicate it with adding like a self-cleaning function, I don't know. I mean, we're off of a software topic.
Yeah, I mean,
I don't know what the control system would be for determining when to clean a toilet.
Yeah,
I do. I just don't want to think about it.
Well, it's kind of like a Roomba where if you clean, like the Roomba is not the best at the best vacuum. Like it's not better than a human at vacuuming accurately, but it just runs so many times that eventually it works.
Okay. Well, that's all I've got for robotics for now.
Cool. Yeah. If you've done any cool robotics work, let us know. Post on Facebook. Facebook seems to be taking over in terms of number of people. I'm obviously going to keep posting the show on all of them: Facebook, Twitter, G+, and now LinkedIn. A few people asked me to post on LinkedIn, so I've done that. But yeah, if you have a toilet cleaning robot that you want to show everyone, post it on Facebook, and we could talk about it.
All right. Well, till next time.
Catch you guys later.
The intro music is Axo by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.